Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. All the candidates who are joining me on YouTube, just quickly confirm whether my audio and visual quality, everything is clear, and do not forget to like, share and subscribe this session so that you get the maximum benefit out of this session and we can join maximum people in this session. So friends, today we are going to start the electrical machines part of the series. We have started a score booster series for your coming Vizag 2020 examination. Hi Narayan, how are you? Welcome to the session. So we'll be discussing some of the important questions of electrical machines. Now let me tell you, it is not possible to judge exactly what are the questions which are going to be asked in your coming examination, but if you see, I am going to take some sample questions in these sessions which will give you an overall idea, a quick revision, and one simple question understanding will give you enough understanding for solving almost 5, 10, 15, 20 questions. If a question comes from that topic, then definitely you will be in a situation to handle those questions effectively. So quickly like the session. Just quickly tell me. Hi Sudhanshu, how are you? Welcome to the session. Everybody just confirm and just hit the like button, share and subscribe this session so that maximum people can be benefited out of this session. Now without wasting much time, I will be starting the session, and let me tell you, we are going to discuss most important questions for Vizag 2020, and this is part 1, and tomorrow 10 PM in the night we are going to have the second part of this session. So let us start quickly. Now some of you may be joining me for the first time, so this is my brief introduction in front of your screen. My name is Ashutosh Saxena and this is my brief profile as you can see on your screen. Everybody is okay with this? Now just see the first question on your screen. First question on your screen. Try to solve it and tell me what is the answer you are getting. Everybody, quickly like the session, share and subscribe. Jaldi, jaldi, jaldi. Okay, let us start discussing the question. See, he is saying there is a 4-pole DC machine which is having 100 armature conductors, and he is saying that the EMF induced in each armature conductor is 2 volts and the speed is 1000 RPM, and the maximum allowed current in each armature conductor without overheating is 10 ampere. And he is asking the resistance of each conductor given as 0.01 ohms, and he is asking you the ratio of armature copper losses for the lap and wave winding. Everybody is getting that? Now see, if you want to find the armature copper losses, whether it is lap winding or wave winding, the first thing you have to understand that anyhow you have to find IA square RA. This is going to be the armature circuit copper loss. It means you have to find the armature current for both the conditions, for the lap winding and the wave winding, and you have to find the armature resistance for lap winding and wave winding. First thing, suppose this is your machine. If you are not okay with the basics, suppose this is your machine, this is your DC machine, and these are the different parallel paths available in the machine like this, and this is how it is connected. Now suppose any one conductor in this parallel path is like this. Any one conductor in any one parallel path is like this. Now suppose you know what is the resistance of this conductor. This is single conductor. This is single conductor and you say its resistance is small r. There can be number of conductors in each parallel path. If he is giving that there are total z number of conductors, then can you tell me what is the total number of conductors in each parallel path? Total number of conductors divided by A. What is A? Number of parallel paths. It means in one parallel path, this much number of conductors are present. So if one conductor resistance is small r, what is going to be the total resistance of one parallel path? Multiply by small r. But there is a problem. What you have found is the resistance of each parallel path, that you have found as z by a multiplied by small r, but you have to find the effective resistance of all these parallel paths. So total effective armature resistance is going to be z upon a r into 1 upon a, because all these paths are going to be connected in parallel. So this is the effective formula you are going to use to relate the armature resistance of the lap bound and the wave bound machine. Everybody is getting that? Tell me yes or no. Everybody is getting that? Tell me yes or no quickly. So this is how you can correlate the lap bound and wave bound machine armature resistance. This is the first thing. Now he is saying armature current. How you are going to correlate the armature current? He is saying it is a 4-pole machine. He is saying number of poles are 4. If it is a lap bound machine, if it is a lap winding machine, then number of parallel paths are equal to number of poles, that is equal to 4. So the situation is like this. There are going to be 4 parallel paths. 4 parallel paths. And each parallel path, he is saying, without overheating, the current is 10 amperes. So each parallel path current is going to be 10 amperes. So what is going to be the total current? This is going to be 40 amperes in case of lap winding. If you come to the wave winding, in case of wave winding, irrespective of the number of poles, the number of parallel paths are always 2. The number of parallel paths are always 2. So you can draw, there are going to be 2 parallel paths. Current without overheating 10 ampere here, 10 ampere here, total current is 20 ampere. So you know the current in both the cases and you know the armature resistance in both the cases. So can you find the ratio? Can you find the ratio? Can you find the ratio? Tell me yes or no, all the candidates who are joining me. Just quickly tell me. Suraj, 1:4 is not the correct answer. Current you have got for the lap, for the case of lap winding, for the case of lap winding, you have got the current as 40 ampere. Calculate armature resistance for the lap winding. What is the formula? The formula is small rz upon a square. Let's apply this. Small r is given, number of conductors are 100 and number of parallel paths are equal to number of poles for the lap winding. So this is going to be 4 square. You can solve for it. Similarly, you can solve for the wave winding also. And if you find the ratio, you will be getting the answer as 1:1. Everybody is getting that or not? Tell me yes or no. Everybody is getting 1:1 or not? Tell me yes or no. So what we have done, we have seen the armature circuit copper loss ratio with respect to the lap winding and the wave winding. So you have to find the current effectively and the armature resistance, and you can find the ratio. Everybody, if you are able to get it, just tell me yes or no. Quickly move on to the next question. Try to do this problem. All the candidates who are watching me, quickly like the session, share it and subscribe it. देखो 45 सीटें हैं वाइजेग स्टील में, ठीक है, और 45 में से अगर इंटरव्यू में जाना है तो ये मान के चलो कि किसी भी हालत में 80% जो टेक्निकल सेक्शन आप अटेम्प्ट करोगे 80% वो आपके हाथ में होना चाहिए. नंबर ऑफ सीट्स जो है वो 45 है, तो जो इंटरव्यू के लिए कॉल आएगा वो बहुत अगर आएगा मुझे लगता है तो 3 टाइम्स ले लो, इससे ज़्यादा नहीं आएगा. तो आपको रिटेन में बहुत अच्छा परफॉर्म करना पड़ेगा, ये समझ लो. एवरीबॉडी इज गेटिंग दैट? नाउ जस्ट रीड दिस क्वेश्चन केयरफुली. रीड दिस क्वेश्चन केयरफुली. Read this question carefully. Now see, these questions are not that simple questions, but if you understand these questions, the analysis, the understanding that I am trying to develop with you, if you are okay with that, the number of questions you will be able to solve. Everybody is getting that? Now see, just try to read this question and see what we are supposed to do here. There is a 4-pole lap bound generator which is running at 900 RPM. If self-inductance is this much Henry, armature current is 108 amperes and number of segments, what is this? This is commutator segments. Commutator segments. We'll understand how exactly commutator segments current is flowing and everything we'll discuss. He's saying width of the brush is 1.74 segments and he's asking the reactance voltage. What is going to be the reactance voltage? Now first you have to understand what is reactance voltage. What is reactance voltage? First you have to understand. If somebody asks you what is the reason why reactance voltage is there in the coil undergoing the commutation, the coil which is undergoing the commutation is going to have inductance because it is inductive coil, and the self-inductive property of the coil says that it will not allow the sudden reversal of the current. What is commutation? Commutation is sudden reversal of the current in the commutating coil, and the self-inductance property of the coil will not allow that. For that purpose, because of the self-inductance property of the commutating coil, a voltage is generated, induced, that is called reactance voltage. So what is the reason of this reactance voltage? Self-inductance of the commutating coil. Now, this reactance voltage which is induced in the commutating coil is going to be dissipated in the form of arc when the brush is going to move from one commutator segment to another commutator segment. This is your commutator segment. Yes or no? So brush is initially suppose going to be here at this place and commutator is moving in this direction. So after one commutation period, what is going to happen? This is going to be the new brush position. This is new brush position. After commutation period. What is commutation period? Commutation period is the time in which the current in the commutating coil is reversed plus IC to minus IC. When there is a complete reversal of the current in the commutating coil, we call it as commutation period. Are you getting this? Now see what is happening. you know that reactance voltage is given as L di by dt. You know this L di by dt. What is this di? Change in the current. What is the change in the current? You know, this is the ideal commutation, plus IC to minus IC, and this duration we are calling as the commutation period. This duration we are calling as commutation period. So what is the total change in the current plus IC to minus IC? This is going to be L to IC. And what is the time? Time is going to be commutation period. So in order to find the reactance voltage as asked in this question, you have to find what is IC and what is TC. Okay. Is it clear? Now see, armature current is given as 108 amperes. Armature current is given as 108 amperes. So current you can find, no problem. The problem is how to find the commutation period. Everybody is getting this or not? Yes or no? Just tell me. Yes. How to find the commutation period? This is the crux. If you have any doubt regarding whatever theoretical portion I am discussing, you can ask me. Now listen very carefully. Just go back to the question and see what is the information he has given. He is saying that the speed of the generator is 900 RPM. What does it mean? It means speed of the generator is 900 RPM. What is RPM? Revolution per minute. It means 1 minute it is making 900 revolutions. So what is the time for one revolution? It is 1 upon 900 minutes. If you want it in second, you can multiply it by 60, you will get it in seconds. This is the time for one complete revolution of the armature, you can say. Now if there is a one complete revolution of the armature, all the commutator segments are going to be completed. What is the total number of commutator segments? 55. So if you want the time to pass one commutator segment, then you have to divide this time by 1 upon 55, 60 upon 900, and this is for one commutator segment time, but he is saying the commutation period will be given by the width of the brush, because brush has to move from one commutator segment to another commutator segment, and the brush width is given as 1.74 commutator segments. It means the commutation period you can find as TC as this much, 1 upon 55, 60 upon 900, and this is multiplied by 1.74. Everybody is getting that? Tell me yes or no. Are you getting this? Are you getting how to find the commutation period or not? If you understand this, whatever type of question they are going to ask for the commutation period, you will be able to do it. Now the question is how to find this current IC, because inductance you know what is the inductance. What is IC? Now IC is going to be current in each parallel path. IC is going to be armature current in each parallel path. What is the number of parallel path? It is a lap bound machine. It is given. It is a lap bound machine, 4 poles. So number of parallel paths is equal to number of poles, that is 4. So you are going to put here 108 amperes divided by 4. So IC value you can put, L value is given in the problem, time period, commutation time period you have found, so you can get it. Everybody is getting this? देखो इससे अच्छी क्वालिटी के क्वेश्चन मिलेंगे नहीं. अगर ये क्वेश्चन कर पा रहे हो तो वाइजेग में तो बहुत ही अच्छा करोगे, और अगर डाउट है तो 10 बार पूछो. इफ यू हैव एनी डाउट यू कैन आस्क मी n नंबर ऑफ टाइम्स. ओके. at least कम से कम at least say yes, no, yes sir, we are getting, at least. Are you getting this? Anyone calculated? What is the answer? Tell me. What is the answer are you getting? And if you want me to repeat how to find the commutation period, I can repeat also. Clear? Okay. You just calculate this value. As per my reference, 3.915 will be the value of the reactance voltage. Just calculate it and confirm back to your home. It is going to be this much. Next problem. Let's try to do this. This problem deals with the compensating winding. So we will try to understand each and everything about the compensating winding by using this question as an example. Let's try to read the question. Ramadasu Yashwant is saying, sir, please explain the formula again. E. Listen carefully. Listen. Reactance voltage, we are saying L di by dt. What is L di by dt? Can you tell me what is L di by dt? Do you want to see L di by dt? How many candidates want to see L di by dt? If you want to see, I will show you. If you want to really see what is L di by dt, I will show you. Have you seen transformer? Have you seen transformer? Yes or no? V1 here. This is L di by dt. The EMF induced because of the self-inductance property of the coil is called as L di by dt. Now, in case of commutation that we are discussing, this L di by dt is actually the reactance voltage which opposes the change in the current, sudden reversal of the current in the commutating coil. Are you getting this? Now, current is going from where to where? Current is going from plus IC to minus IC. So, what is the total change in current? It is going to be 2 IC. What is the time period? Commutation period. I hope you will not be having any problem. Okay, you want to know how it is 2 IC? अरे बाबा, 2 IC नहीं समझ पाया अभी तक? कैसी बात कर दी? Now, this is going to be plus IC. This is going to be minus IC. Are you getting this much? You understand what is plus IC, minus IC? See, if you don't know anything about the machine, I cannot teach you everything in just one question. You must have a background. You must know what is commutation. You must know how the current is going from plus IC to minus IC. Everything cannot be completed. So you are going from plus IC to minus IC. What is the change? 1 IC, 2 IC. What is the problem with that? Are you getting this? Now just see this question. What he is saying? He is saying calculate the number of conductors on each pole piece. Conductors on each pole piece, it means if your pole is like this, then conductors are going to be placed in these slots. Are you getting this? Conductors are going to be placed in the slots provided in the pole shoe. So he is asking the number of conductors placed in each pole piece to compensate a 6-pole lap-bound DC armature containing 286 conductors The compensating winding carries full armature current. The compensating winding carries full armature current. Assume the ratio of pole R to pole pitch as 0.7. I will give you some understanding. What is happening in the compensating winding. Just have patience. 1 minute we'll discuss. Suppose this is your compensating winding. This is going to be your compensating winding. And this is your armature coil. Okay. Suppose this is the direction of current in the armature conductors. So if you have to find the flux direction, what is that? Apply the right hand thumb rule. Thumb in the direction of current, moving fingers will give you the direction of flux. So for these armature conductors, the flux is going to be anti-clockwise. It is going to be anti-clockwise armature flux. If you are going to provide current in the compensating windings, suppose the current direction is like this, they are connected in series with the armature coil, and if you find the flux because of the current in the compensating winding, it is going to be clockwise. It is going to be clockwise. This is compensating winding. So what is the Nazara? The Nazara is that compensating winding neutralizes the cross magnetizing effect of the armature reaction under the polar region, under the pole shoe. This is the pole shoe. Under the polar region, the cross magnetizing effect of the armature reaction is being nullified or compensated by using the compensating winding. Now, I want to write ampere turns of the armature per pole, because I want to know what is the number of conductors I have to place. So first I will find the total ampere turns of the armature winding. That is going to be how much? Now you tell me, what is ampere turn? Ampere turn means current multiplied by number of turns. Number of turns and divided by P, that is number of poles. Now you tell me, if you have a DC machine, what is going to be the current in each turn? I am asking you current in each turn. Suppose there are 4 parallel paths. Suppose there are 4 parallel paths. You tell me what is going to be the current in each turn. This is going to be IC, 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 IC. Can you tell me what is the current in each turn? Yes or no? What is this current? This current is IC. What is IC? Armature current divided by the number of parallel paths. It means you have got what is the current in each turn. What is the number of turn? Now one turn, you will be getting, this is 1 turn. You are getting 2 conductors. 2 conductors ABCD are required to give you 1 turn. So if there are Z number of conductors, how many number of turns? Z by 2. It means you can write the ampere turns of the armature winding per pole. It is going to be IAZ upon 2AP. This is something you have to always remember. This is something really, really important, very, very important. Ampere turns of the armature winding per pole. Now you want to compensate. You want to compensate. When you have found the ampere turns of the armature winding per pole, it means it is giving you the compensated armature conductor ampere turns for 1 pole pitch. For 1 pole pitch you have found. It means if this is your machine and suppose you have 4 poles. Suppose you have 4 poles like this. Okay. So what you are doing, you are placing the compensating winding here, but what you have found is the ampere turns of the armature winding for one pole pitch. But compensating windings are only going to be present up to the pole arc. It means ampere turns of the compensating winding will be equal to pole arc upon pole pitch IAZ upon 2AP. This is the final formula. I think you will never forget this formula now. Just put the values, you will get the answer. Pole arc upon pole pitch is given as 0.7. IA current is given as, okay, no problem. You can take the current as it is. Number of conductors 2AP. Now what is this ampere turns of the compensating winding? Again it is going to be current in each turn and number of turns. So what is the current in each turn? Because compensating winding is connected in series with the armature winding. So current is going to be IA, and these are the number of conductors divided by 2. That will give you number of turns. Everybody is getting that? Everybody is getting this formula? Now IA is going to be cancelled. That is why IA is not given in the problem. From here you can calculate the conductors present in each pole piece of the compensating winding. And what is the answer you are getting? Let me just give you. Approximately you will be getting 6 as the answer. You can confirm it back to your home. Everybody is getting that? Everybody is getting that? Thank you, Chavi. Welcome to the session. Everybody is getting, just say, just quickly like the session, like, share and subscribe. Very good quality problems we are doing. Suraj, just check your calculation. I think you must be getting somewhere close to 6, but because number of turns can always be, number of conductors can always be in integer. It cannot be non-integer. So that is why close to 6 you are getting. So you are taking 6 as the final answer. Now just read this question carefully. Read this question carefully. Very easy problem, direct formula based. And if you have understood the previous problem, it is going to be quite easy for you to understand this. He is asking the cross magnetizing and demagnetizing ampere turns because of the brush shift. Now you tell me, suppose this is your DC machine. This is North Pole. This is South Pole. This is North Pole, this is South Pole, and suppose you are going to place the brushes like this. This is how you have placed the brushes. You have shifted the brushes in the direction of generator rotation, and suppose this is the situation. These are your armature conductors. These are your armature conductors, and if you apply the Fleming's right hand rule, you will find the direction of current. Direction of current you will be getting as cross under the North Pole and dot under the South Pole. Now see what is happening. Because of this shifting of the brush, what is happening? Because of this shifting of the brush, what is happening? Just see here. If this shifting angle is theta electrical, then this angle is also going to be theta electrical. So what is happening? The conductors which are present in the cone of 2 theta angle, they are going to give you what? This is going to be the direction of, main field flux, and armature flux is going to be opposite to this. So these 2 conductors top and bottom, they are going to give you the demagnetizing effect. Are you getting this? This is because of these two top and bottom conductors. If you apply the right hand thumb rule, it is going to be completely opposite to the main field flux. So this is going to be demagnetizing. And rest of the armature conductors beyond this cone, they are going to give you cross magnetizing effect, because it is going to be 90 degree. This is cross magnetizing effect. Are you getting this? So if you have to find the ampere turns of the armature winding with reference to, suppose you want to find for demagnetizing. So what is the total ampere turns of the armature winding? IAZ upon 2AP, we have just seen. Now only 2 theta electrical angle is going to give you the demagnetizing effect. Out of this 180 degree, only 2 theta angle is going to give you demagnetizing effect. So it is going to be 2 theta E upon 180 degree electrical. This is the formula you have to use. Ampere turns of the cross magnetizing effect, if you have to found, then it is going to be 180 degree minus 2 theta electrical upon 180 multiplied by IAZ upon 2AP. Everybody is getting that? Everybody is getting that? Just tell me yes or no. Can you put the values and solve this? Now after this, only high school mathematics is required to get a selection in the Vizag Steel. 45 seats, your written paper should be very, very good. Then only you have a chance to go for the interview. So you cannot imagine a single mistake in the written examination. You have to be 100% sure. Are you getting this? Just tell me everyone, yes or no. Everybody getting that? Everybody is getting that? The best thing is that whenever I ask you, are you getting this or not, nobody is responding. At least hit the like button, share, subscribe, and tell me whether you are getting this or not. Anyways, let us go to the next problem. I hope you can solve it. Read this question carefully. Read this question carefully and let us see what we are going to do. See, this question is asking about number of turns required on each interpole. Number of turns required on each interpole. Now you have to first understand some basic idea about the interpoles. Suppose this is your machine. These are the main field poles. These are the main field poles. Suppose this is north, this is south, this is again north, this is south. And suppose you are having small poles like this. These small poles we are calling as interpoles. These are interpoles. Now if you see for the generator, suppose this is the generator rotation direction. So how to decide the polarity of these interpoles? For the generator you can say the polarity of the interpole is always the main pole ahead, because generator always looks ahead. So this is the logic you can apply. If you have to find what is the polarity of these interpoles, so if you are a generator you will always look forward. So in the direction of rotation you look forward. What is the next main field pole? That is south. So this is going to be south. Standing here and looking forward in the direction of rotation, what is the next main field pole? North. So this is going to be north. Standing here and looking forward in the direction of rotation, south. So this is south, and again this is north. If it is the case of motor direction rotation is opposite. Are you getting this? So if you are rotating in the motor direction, then you have to see the main field pole behind. If you are deciding the polarity of this pole, then it is going to be north, because in the direction of rotation you have to see behind, because for the motor it is reversed. So this is how you are deciding the polarity of the interpoles. But what is the purpose of interpoles? The compensating windings were compensating the cross magnetizing effect of the armature reaction under the polar region, whereas these interpoles are going to neutralize the cross magnetizing effect of the armature reaction under the interpolar region. Are you getting this or not? The responsibility of compensating winding is to neutralize the cross magnetizing effect of the armature reaction in the polar region, whereas the interpoles, it neutralizes the cross magnetizing effect of the armature reaction in the interpolar region. One important difference between the main poles and the interpoles is that their air gap is long. Air gap is large. Okay, if air gap is large, so the reluctance is also going to be large. It means whatever ampere turns means MMF, whatever ampere turns or the MMF you are going to provide to the interpole winding is also connected in series with the armature winding. So the current is going to be same as the armature current, and whatever MMF, ampere turns of the interpole winding you are going to provide, you have to take care of two things. What are those two things? Number one, what is NIIA? Ni is the number of turns, Ia is the current in each turn, that is armature current, because interpole winding is connected in series with the armature winding, because it has to neutralize the same MMF, same current. So this ampere turns of the interpole winding has to take care of two things. Number one, what? The cross magnetizing effect of the armature reaction in the interpolar region, and to overcome this air gap reluctance. Now, ampere turns of the armature winding, you can write IAZ upon 2AP. IAZ upon 2AP, we have just calculated it. Plus, what is MMF? Remember, H dot dl is equal to Ni. So this is going to be H into L. H is going to be B upon mu naught. So this you can write as B upon mu naught, and this is going to be Lg, that is the air gap length. Use this formula, put all the values, and you will get the number of turns in the interpole winding. Everybody just tell me, are you getting this or not? Okay, so as per my reference, you will be getting approximately Ni as 74. What is the correct answer? A. Everybody is okay with this? So friends, before I conclude the session, let me tell you that tomorrow also we are going to have, tomorrow is Sunday, what is the date? 6/12/2020, 10 p.m. in the night, I will be coming live Gradeup Gate YouTube channel, and we'll be discussing some more important questions, concepts related to your coming examination, Vizag Steel 2020. But before I conclude, let me tell you for all my audience some important details about the Gradeup Super now or never opportunity. 9th of December, till 9th of December, the prices have been heavily slashed. So if you want to go for the subscription, let me tell you, the subscription are for 12 months, 18 months and 24 months. Just one Gradeup Super subscription will take all your preparation worries, whether it is live classes, mock tests, test series, whatever it is for AC and GATE. Now friends, as I used to tell you that Gradeup Super has become a one-stop solution for all the preparation of different category of students. If you want theory, Gear Up is for you. If you want questions, then Rank Up is for you. If you want theory and numerical both, then Vision 2020 is going to be the best course for you, most exhaustive course, 850 hours of live classes. Can you imagine? For any guidance, any doubts, any information, you can contact this number, and I think you are going to be assisted in the best possible way. Any doubts, you can ask me. These are the faculties who are going to mentor you throughout your preparation. You must be knowing most of them. Each faculty is going to be very experienced and expert in their respective field. These are the results we have produced over the years. 2020 has been a landmark year when we have produced 60 plus Gradeup students under the 100 rank. Their testimonials are available on our website in the app, and you can go through them to get motivated for your own preparation journey. So my friend, Gradeup Super Subscription, just one subscription gives you all the structured live courses and all the mock test series green card access. So this is all about for today. Do not forget to like, share and subscribe this session. I want maximum number of people for the tomorrow's session so that it is going to be a really successful session. Thank you so much for joining me in this session. All the best wishes from my side for your coming Vizag 2020 examination. And remember just one thing, only 45 seats. If you want to get a call for interview, your written examination must be very good. Are you getting this? Are you getting this? Thank you so much. Take care of yourself. Prep smart, score better. Go Gradeup. Thank you so much. Thank you everyone. Thank you. Take care. Thank you.